So way back at the beginning of this course, we said that there are two fundamental rules for solving every algebra equation. The first rule is this one. We see what's being done to the variable, usually x, and then we solve it by doing the opposite. So if you had to solve 3x equals 12, you see what's being done to x, it's being multiplied, and you do the opposite, you divide. That was the first rule. The second rule is whatever you do to one side, you have to do to the other. So if I divide one side by 3, I have to do the same on the other. That exact same strategy is going to be the strategy we use to solve logarithm equations. The only difference is we have to figure out what is the opposite of taking the logarithm, and this is what it is. The opposite of taking the logarithm is raising something to an exponent, and vice versa. The opposite of raising something to an exponent is taking the logarithm. So in all three of these examples, we're raising something to a power, and the opposite of that is taking the log. So I'm going to show you the wrong way that most people do this. Suppose I wanted to solve this equation. A lot of people would say, oh well, 2 to the x, that means I'm going to divide by 2, and 8 divided by 2 is 4. And that's wrong, because if you put 4 in here, 2 to the 4th does not equal 8. 2 to the 4th equals 16. So clearly we can't divide. Dividing is not the opposite of raising to a power. It's the opposite of multiplying. And we're not multiplying here, we're raising to powers. So here's what we need to do. We need to take the log of both sides, and then we'll use that property we talked about before, and this is the property I'm referring to. We said the log of a to the b, that's the same as if you took this and you just put it in front like so. So we will use that to our advantage as we're solving these equations. Alright, so let's start with number 1. So we need to somehow get this power to come down, and we can do that, as we just said, we can do that by taking the log of both sides. Okay, whatever I do to one side has to be done to the other. Now at this stage we can use this property. You can't swing the x in front until you've taken the log. That's important. So now that we've taken the log, we can move this in front. So we have x times the log of 19 equals the log of 15, and then x is being multiplied. Now we can divide by both sides, and then I want to show you how to put this correctly in the calculator, because this is often the most challenging part of this problem, is putting this in correctly. So we have log of 15 over log of 19. So let me just clear this off. So here's how you would do it. You do log of 15, and then I have to close this parentheses and make a second log. So divide by log of 19. What a lot of people do the wrong way is they will forget to close that parentheses, or they'll just do a single log 15 divided by 19. That's not what you want to do. So our answer here is 0.9197, and usually on these problems you tend to round to the 4th decimal place, because a lot of these problems involve science applications where you need to be somewhat precise. So there's our answer. Very easy to check too. We can always plug it back in right here, which I'll do right now, and we'll see that we get the right answer. So these answers are easy to check. So let's do 19. This symbol that just lit up in red, that's the power symbol. And then instead of doing 0.9197, I'm going to do second and then answer. Answer is right above the negative key. What that does is it gives you the exact answer right there, not just the rounded answer. Will give you that big long decimal right there with however many decimals it has. We should get 15, and actually you can't. Let me move it so you can see it. Now you can see we do get 15 as our answer. So that's a nice and easy way to check. Alright, see if you can pause the video and try numbers 2 and 3. The strategy is the same as before. There's a couple more steps, but otherwise the same procedure. Alright, so again on number 2 we need to do the same thing. We have to start by taking the log of both sides. And when you can take the log with any base that you want, but in this case we're not writing a base, so that means a base of 10. Okay, so now we can use this property. We need to take this and move it in front. Here's one thing to be cautious of. I'm going to write it right here. I'm going to write this the wrong way, and I want you to think about why what I just wrote is wrong. Because as I wrote it right there, it is wrong, and the reason it's wrong is because we need to, just like we did over here, we multiplied this entire thing by log of 19, but the entire thing was just one variable, was just x. Here, the way that I've written this right now, I'm only multiplying 3 by log of 6, and what I actually want to do is I want to multiply this entire thing by log of 6. So you always need to put a parenthesis around that so you can avoid getting the wrong answer. Okay, so we'll divide both sides now by log of 6, and then we'll get 7n minus 3 equals this number right here. Again, the challenge here is going to be putting this in the calculator correctly. So we'll add 3 to both sides, and then we get 7n equals this. And our very last step, I'm going to show you how to do this in the calculator in just a sec, is take both sides, divide this whole thing by 7. So you can see this is going to be kind of a mess to put that in the calculator. So let's see how we would do that so we can get it right. So here's what we need to do. You can see, let me just expand this a little bit. Oops, so we're supposed to be doing this. We're supposed to have log 59 divided by log 6 plus 3 divided by 7. So here's the best way to do this. I would recommend doing it kind of one part at a time. So log 59, close parentheses, divided by log of 6. And at this point I would now press enter. You could keep going, but a lot of people are going to make mistakes with having the right parentheses, so I strongly recommend you do it the way I'm going to show you right now. So press enter, we get this number, then we were supposed to add 3. So all I did was hit the plus button, and that ANS right there, that means answer. That's referring to the previous answer, 2.27. So it's using that same number and adding 3 to it. And then the last thing we were supposed to do is divide by 7, and there's our answer. 0.7537 is what it would round to. And again, you can check that by plugging it in if you wanted to, but you don't have to do that as long as you are sure that you did it correct. It's never a bad idea to check, though. Alright, this last one is slightly more complicated. Really the same thing, there's 2 extra steps. But before we solve this, here's a question for you. Would you be able to solve, suppose I gave you this equation right here, and I said solve that for x, would you be able to solve that? And hopefully you would say yes. You would say I would have to add 9 to both sides, and then I would secondly have to divide by 10. And if you said that, you'd be exactly right. That's the exact same steps we're going to use over here. This whole thing right here, this is the power. So it's kind of like on the previous example we had 6 to the 7n minus 3. I'm just taking this power, this exponent right here, and I'm replacing it in this case with the letter x. So we can see that. So x is the same as this right here. The reason we're doing that is because we can't start doing all our properties where we take the logs. We can't do that, and we can't move this in front until everything around it is cleared away. So that means I have to begin by adding 9 just like I did over here. So I'll have 10 times this right here, and then 7 plus 9 is 16, and then I have to divide by 10. I can't use my property until I've done that, which we have now done. So 16 divided by 10 is 1.6. Now at this point we can use our logarithm property where we take the log of both sides and move it in front. So see if you've got to that point, try and pause it and see if you can do the rest. So we have this. Now we can take this and plug it in front, and remember that we need to put a parentheses around that. So the whole thing is getting multiplied by the log. And just a couple more steps here. Now we need to get rid of the log of 16, divide both sides by log 16. And so we're left with this 6 minus 9a equals this right here. And we can't, it's not like you can do 16 over 1.6 over 16 and somehow simplify those. Those are 2 different logs. You have to keep them separate. So this goes away. We get negative 9a equals this whole thing right here. And the very last thing to do is divide by negative 9. Divide this whole thing by negative 9. So this in parentheses is what we need to put in the calculator. So let's do that. So we have log of 1.6, and we're going to divide that by the log of 16. And then after that, so let's press enter first. After that, what we needed to do was subtract 6, and so we will do minus 6, and then finally we need to divide by negative 9, and when we do that we will get an answer of 0.6478. So that is our answer for x, 0.6478. Let me just write that down, and that is how we solve log equations. So hopefully that makes sense.